Very good. So let's take a look at the following. Let's say we have 3 to x plus 1 minus 2. So we want to graph using transformations. Graph using transformations. First, I have to identify the base function, or the original function that I used here. And we know tons of functions now. We know linear, we know quadratic, we know the square root, we know the rational function, we know the absolute value, we know the cube root. What function is this? What did I use to create f of x? Anyone? Well, I use the function 3 to the x, of course. That's the base function. Then we have to decompose it first into 3 to x plus 1, and the second transformation is this. Can anyone tell us what transformation is this and what transformation is that? And then we are ready to graph it. Are we changing x from here? Are we changing x or are we changing y? Well, we're changing x, right? Because when we change x into x plus 1, the graph shifts left 1. And then from here, we're changing y, down 2. So now let's graph. Will 3 to the x be increasing or decreasing? That's basically all I need to know at this point. Increasing or decreasing?
Increasing.
Excellent, because the base is greater than 1. Very good. And you will have to cross at 0, 1. All base functions exponential with base greater than 1, they will cross at 0, 1. Then we decided to move this function left 1. When I move this function left 1, all I have to do is move my marker. This is my marker point. I will move it left 1, and I graph again the same function. So this is 3 raised to x plus 1. Finally, you told me to, I think you did, told me to move down 2. Okay, I'm looking at my point, 1, 2. So this point now moves here. But we have to stop for a moment, because this function, both functions, had a horizontal asymptote. What was the horizontal asymptote of these two functions? The horizontal asymptote was?
0.
Yes, excellent. Y equals 0. But now, when I move the graph, I first have to move the asymptote. Where will the asymptote move? I'm moving the entire graph down 2. So where will the asymptote go?
There's 2.
Excellent. Well done. Thank you. And now I can finish up my graph. I have no idea where it crosses the x and y axis. I really don't know. Of course, my graph is not perfect. So this is the graph of 3 to x plus 1 minus 2, using transformations. Yes, later on we will be able to determine. So if I can determine right now, 0, 3 minus 2, so it's 1. So the graph really crosses here, and I can make the adjustment. But I'm not really interested at this point, right? Because when x is 0, 3 to the first power is 3, 3 minus 2 is 1. So I can adjust that. But I'm not interested in details till we are able, we will learn how to how to solve exponential equations to find the y-intercept as well. Okay. Any questions on this? Any questions? I want to look at the book, just a couple of questions from section 4.1, because there are tremendous applications here, very interesting. Section 4.1 starts on page 474, and I would like us to look at a word problem to see when we apply exponential functions. Okay, are you interested in the population of India? Problem 65. Or are you interested in the explosion of at the Chernobyl plant? Are you interested in how the information, yeah, this is an interesting problem. 73, let's start with 73. And you'll see the applicability of the exponential function in real life situations, when no other function works but exponential. Okay, so I'm on page 7. So we are looking at 73 on page 476. Okay, so in college we study large volumes of information. Information that unfortunately we do not often retain for very long. The function f of x equals 80 times e to negative 0.5x plus 20 describes the percentage of information, percent of info, that a particular person remembers x weeks after learning it. Find the percentage of information remembered at the moment it was first learned. Okay, so let's take a look at this situation first of all, and we see a base of e. And I will say that there are two special exponential functions. One of them with base e, and the other one with base 10. They are so special that they have their own key in the graphing calculator. See right here in blue, 10 to the x with the second key, and this one e to the x also with the second key. So 10 to the x is called common exponential function, and it has its own key, and this one is called natural exponential function. The reason why it's called natural is because it really appears in a lot of natural situations, in real life situations, in nature. So both of these, in case you forgot what E is, very easy to come up with E. It has a special key, so important, it's right here, also with the second key. So in blue, with the division symbol. So second and E, and you press enter, it will tell you, it will give you 8, 2, 4, 6, 9 decimal digits, 2.71. So it's a number greater than 1. Both E and 10 are numbers greater than 1, so both will follow the same shape. Both will cross at 1. One of them will be closer to the y-axis, which is base. The higher the base, the closer to the y-axis. So this will be 10 to the x. And the other one will be slightly further away from the y-axis. The red one is e to the x. Same shape, same cross, because when x is 0, still this is 1. Okay, so we discovered the fact that the function is, I mean, we know that the function is given to us, and it relates number of weeks, x, to the percentage of information that we still retain after such and such weeks. Every time we are asked to determine the percent that is initial or original or at the beginning, NG, all these are really asking us to plug in 0 for x. If I'm asked to find the initial value, the original value, or whatever happened at the beginning, I have to determine f of 0. So this is part A. In a minute, we'll plug it in. Part B, they want to see what happens after 1 week, and then 4 weeks, and then 52 weeks. So in part B, they want us to find f of 1. In part C, f of 4. And in part D, they want us f of 52, a year later. I don't want to do these step by step. I want to put this in the graphing calculator under y equals. Clear if you have anything else. So let's carefully plug in this function, 80. Stop me if you have questions anytime, please. Careful with the e. E is right here. Plain e with no power is here, but e to the x is here. So second and e to the x. Please bear with me and put this in parentheses. I don't know if they are required, but I think it's better if we put 0.5x in parentheses, close the parenthesis, come down and put plus 20. Let me know if we have this. Do we have this?
Yes.
Perfect. So now, let's go to second and table. I'm assuming you haven't made any changes and you still have second and table set. You have the independent variable in the ask mode. So second and table, and I'm going to put these numbers in one after the other, 0, 1, 4, 52. 0, enter, 1, enter, 4, enter, 52, enter. And put all 4 answers at once. So 100% we remember initially. I'm going to round to 68.5. 68.5, after 1 week it drops almost 30%. Then 30.83. In a month, we forgot 70% apparently, according to the model. And after 52, we only know 20% of what we studied last year. So this was an application of the exponential function. This is an exponential function with a base greater than 1. Because it has a negative exponent, it will become an exponential function with a base less than 1. And we see that it's a decreasing function. The initial value was 100. A week later, 4 weeks later, a year later. Any questions about such a function? Any questions?
How did you get to the table again?
Yes, let's do that again. So after you put in y equals, you go with second and table right here. Second and table. But you have to make sure that you have, when you go to second and table set, you have to make sure that the independent variable is in the ask mode, otherwise it will not allow you to put in the x values that you want. Is this okay?
Yes.
So then you get all those numbers at once. Do you have to do this? No, you can just redo the calculation 4 times. But I think it's much easier. Okay. I would like to talk about another application. compound interest. Compound interest can be done in two ways. N times per year continuously. Two different ways. Both involve an exponential function. For the n times a year, you do not have to memorize these models. They will be given to you on test 3 and the final exam. They will be in the problem. So A equals P 1 plus R over N raised to NT. I'll explain each and every letter here. The second one is a totally different function, is E to KT. Okay, this looks gibberish, right? Doesn't mean anything till we clarify what each and every piece represents. From that moment on, you'll see it's not a big deal at all. Okay, so let's start with A. Is the accumulated value. Of course, A is the same. P. Oh, sorry. P. Principal. Say P in both. R. Annual interest rate. N, which does not exist here, number of times interest is compounded per year. Compounded means recalculated. T, number of years. I'm going to use the same R. It's really K in the radioactive substances, the decay, but when we get to that, I'll explain. So let's use the same letter. So RT, R, annual interest rate. So let's see how this works. In other words, let me just explain this scenario. Praise the principal. Let's say we deposit $1,000 today. Let's say at 1%. Compound 4 times a year for 10 years. And the question is, what will be the accumulated value? Same thing here. When the interest is compounded continuously, then it's every second. So there is no number of times per year. It's just every second. It's continuously. So let's look at an example. Find the accumulated value of an investment of $5,000, 54, on page 475. It says find the accumulated value of an investment, $5,000, for 10 years. At an interest rate of 6.5%. If the money is compounded semi-annually, quarterly, monthly, and continuously. I have to move this book, it's so heavy. C, monthly, and D, continuously. Before we attempt anything here, we have to identify what is given to us. Can anyone tell us what is 5,000? What does it represent? Which letter is 10 years? And which letter is 6.5? Remember? 0.065. We cannot use decimal numbers. So, can anyone tell us what is 5,000 from all these?
A, P,
Very good, awesome, great job. And then, what is 10 years from all these letters? T, number of years, T. And what is this from all these letters?
Which one did you go to again?
P is the principal, T is the number, is time, number of years, and now I'm here. Which one is this?
It's going to be the accumulated value, right? For A,
It's the annual interest rate. We do not have the accumulated value. So,
6.5.
yes, annual interest rate. So that's a little r. So now let's write the formula. So A equals 5,000, 1 plus 0.065 divided by n. I'm going to put n here for now. Raised to 10 times n, because 10 is 10 years. T is 10 years. Of course, you can repeat the process as many times as you need. So first of all, A, what does semi-annually mean? Number of times interest is compounded per year. So semi-annually, n for A, n equals, part A, n equals
6.
2, semi-annually, okay.
Yeah, 2.
Part B, yes, for quarterly, n equals, we have 4 quarters in a year. For monthly, 12, and for continuous, it's a totally different formula, 5,000 e to 0.065 times 10. But these three can be determined by putting in the calculator all this formula. N, we don't have n in the calculator, we have to replace it by x, but it doesn't matter. So in y equals, let's clear and put in this function, 5,000, parentheses, 1 plus 0.065 divided by x. Close the parenthesis, put the power, the caret, power. I have to put parentheses because I don't trust the calculator. I don't know if it works without parentheses, but that's the correct way. And now I'm going to plug in 2 with second and table like we did a minute ago. I will plug in 2, 4, and 12. 2, enter, 4, enter, 12, enter. And just copy my answers. So go and highlight, go back and highlight so you see the decimal correctly. So A here is $9,479.19. A, the second one. Stop me if you have questions. 9,527.79. And the third one is 9,560.92. The third one, it's not here. I have to start from scratch with 5,000. Remember where we find E? E to a power is right here. Second, E to a power. Please put it in parentheses, especially if you don't have a newer calculator. You can multiply these, or if you say, no, I don't want to multiply, just put it in parentheses. 0.065 times 10 and press enter. So this answer, the last one, continuous, is 9,577.70. So this was possible only because we are using exponential functions. So this is the base and this is the power. Principal, and that was continuous. So for continuous, as you see, there are two different formulas. This one for n times a year, semi-annually 2, quarterly 4, monthly 12, And for continuous, I cannot use this formula. I have to use the continuous formula. So you will be given...
A little bit, please.
Say it again.
The paper, can you move it up a little bit?
Is this okay?
A little bit more. Thank you.
Thank you. So you just have to remember not the formula, but the difference between these two. So when you are given the two formulas, then you know which one to use. Any questions?